Hi, and welcome to another episode of Kasper On BI. Today, we're going to talk about AI and machine learning. And to do this, we have a very special guest. I'm very honored that we have Rafal Lukawiecki on the episode today. Rafal has been around for quite some time in this area. I remember him from when I started in my multidimensional days as an expert in the multidimensional data mining add-ins. And he's been using AI and machine learning and teaching AI and machine learning for a long time. So we're going to learn from him. We're going to talk about what is AI, what is machine learning, and how can it help us in our day-to-day lives as BI developers. And with that, let's go hear from Rafal. So hi, Rafal. It's an honor to have you here on the show. It's been a long time, too long, since I've actually seen you face to face, but I guess it's a sign of the times. It's super great to have you to talk about AI, machine learning. So maybe you can share a little bit about what you do and what your company does.
Well, thank you very much for having me here, Kasper. It's a pleasure and an honor. I have been working in this area now pretty much for well over 10, almost 15 years. So I've been in IT ever since. And for the last 15 years, I have focused on what used to be called data mining, then became predictive analytics, advanced analytics, and now we, of course, call it machine learning, data science, and artificial intelligence. So the names have been changing, but the nature of the job that I'm doing, amazingly, has not changed at all. The technology has become better. The tools are much nicer. There's much more need, customers, and knowledge about it, good and bad. But the job really has been pretty much the same since I started. I think the first time I dabbled in it was around 2005, 2006, using SQL Server 2005 data mining components. And I think that's around that time that I got to know some of your colleagues at Microsoft, like Donald Farmer and the team that worked on SQL Server analysis services. I'm not sure when you have joined that team, but that's as far back as I remember hearing about you.
Yeah, for me, I started that only at Microsoft in 2010. But before that, I was already doing some machine learning. No, mostly about multidimensional models and dabbling with data mining add-ins. But it was always actually a hard sell. I remember, and it's a bit random, but I remember I was in a hospital doing something, and the boss came in and he said, "Okay, all the predictions are completely wrong. We're completely off." And they've been doing it in the same way that they had been doing it for 20 years. And actually, they would print out data and they would predict. And then I ran the same numbers coming from the OLAP model in the data mining add-ins, and mine were spot on. And I tried to tell them, like, guys, this is what you should going forward. But they said, we don't trust this. We've been doing it this way, and we want to be doing it this way. So it's a bit of a random thing, but
this is very much still the case. The very first border and barrier that you have to climb over and solve in any business application of machine learning is the barrier of trust. And in the olden days, which sounds like it was 100 years ago, but it's really only 15, 20 years ago, that barrier was insurmountable for some businesses because they saw technology as magic. And we had to work hard on proving our case, explaining and justifying the predictions. Nowadays, it's much easier, and that's not always a better situation to be in, because in the last few years, in particular in the last 5 years, there's been tremendous growth in interest in deep learning technologies and other technologies which generally build inexplicable black box models that even if you wanted to explain, you couldn't. Thankfully, their use is confined to areas which are more to do with recognition rather than reasoning. So deep learning tends to be used for image recognition, sound, voice, rather than for credit scoring or for forecasting capacity or income. Unfortunately, because these models are often inexplicable, and people don't even attempt explaining them, the solution to the problem of trust is that they just go to the business owners and say, trust me because I'm clever. And, that's not a great way of building trust. So one of the biggest problems I'm seeing in the last few years is that people build those incredible machinery, fantastic technologies, models which look and behave wonderfully whilst they are building them in the lab. And the moment they deploy them into the wild, very, very quickly, it all crashes. Yeah, like your example in the hospital. The only difference is that they just throw their arms in the air and say, well, we can't explain why it was working before, and we don't know why it's not working now. And I don't want to go into technicalities of why it doesn't work, but it's actually almost always for a very good old reason. Those models tend to be tremendously overtrained. It was better in the past, I think, that we had to justify our models and our work and build the trust the hard way than nowadays. But anyway, that doesn't apply to everybody. This is primarily the black box builders rather than the rest of the world like us.
Yes. And so maybe, I've known you for many years in the field. So maybe you could talk a little bit about your company too.
Oh, thank you very much. Funnily enough, I have prepared a slide to explain what is it that I do. Would you mind if I switch to it?
No, please go ahead.
Let's see. There we go. So I actually have two businesses. The company that I've worked for now for a long time, over 20 years, is called Project Botticelli Ltd. And it is a small consulting company based here in Ireland, where I live, where we specialize in machine learning, data science, AI, and all of that fancy stuff that I've been doing for a while. And this is also the business using which I teach what I do. And I have two classroom courses. Those are very intensive, hands-on classroom courses that teach everything you need to know if you want to get started in ML or data science. The first one focuses on Azure machine learning, and I just have it coming in a couple of weeks in April. And the other one focuses on using the R programming language and SQL Server. However, I also have another business, which I have started only a few months ago, last year, called techflix.com. And that's a business through which I and my colleagues, like Chris Webb, who happens to be working with you nowadays, and Marco Russo and Alberto Ferrari, the experts in the world of DAX and Power BI, we basically all teach through the medium of self-paced online video courses. And of course, all of us provide consultancy. My area, machine learning, I offer through Project Botticelli.
So great, thank you. That makes a lot of sense. So let's continue on. Let's actually start talking about AI and machine learning. So let's first talk about all the confusing naming. AI, machine learning. Is there actually a difference? What's in the name?
It's a great question, and we could spend a whole day talking about it. To many people, there is no difference, but there is a very big difference, except that it is not being properly seen or looked after. To cut a very long description short, machine learning is a way to deliver artificial intelligence, but it is possible to build AI without ML. And in some ways, it might be better to build AI using both ML and not using ML. So, machine learning is just a bunch of algorithms and a discipline that studies those algorithms that detect patterns in data. By its nature, machine learning is an extension of statistics. Some people call the intermediate thing between statistics and machine learning statistical learning even. And it is probabilistic. What it does is it builds you models that can never say that something is or is not true. They always say that something is maybe true or maybe untrue, and we can measure that probability, and that allows us to use it to make decisions. But that probabilistic nature of machine learning, that fuzziness of machine learning, is fundamental to both its power but also its weaknesses.
Mm.
Artificial intelligence has many definitions. The most common definition is the one that Peter Norvig and his colleagues concocted in the early 2000s, that basically it's a system that perceives its environment and makes decisions that somehow improve its functioning and let it focus and deliver on its goals. So any type of a computerized system that is making decisions and then adjusts itself and its decisions based on the results it perceives is considered to be artificially intelligent. This is a very good definition, but you can build these things using anything. You don't have to use machine learning.
Yeah.
However, as it happens, the most common forms of AI that people usually think of when you say AI, image recognition, talking to Siri or Alexa or whichever other digital assistant, Cortana or whatever else you use, being able to do those incredible language translation feats or winning at chess against human players. All of that stuff is considered nowadays to be artificial intelligence, and quite rightly, because that uses AI. However, there is another huge part of artificial intelligence decision making, which we want to be better at, but we are not, and for which machine learning is not very helpful. And that part of AI deals with making wise decisions, reasoning. For example, deciding whether somebody's loan should or shouldn't be given based on not just probabilities, but actually a deep analysis of the situation of the individual. Or deciding whether a car traveling at high speed on a highway somewhere in Silicon Valley should or shouldn't crash into a barrier made of concrete erected in front with the purpose of protecting people because there's some construction happening behind it. And that car, of course, probabilistically deciding that, well, maybe that barrier is not made of concrete. Why don't we try driving into it and then killing its occupants? You see, using machine learning for those life-death situations, or even not life-death, but making decisions about people's lives, like in the case of giving a loan. And I'm not even going to highlight the really difficult cases like military applications or judgment or policing. I strongly believe that that part of artificial intelligence is the one part where we have the biggest gap between what we want to achieve and what probabilistic machine learning systems can deliver. And that's where the biggest difference is. But most people don't think about that. Or if they drive a Tesla, lovely car, happen to have one, I like it very much, but I have to tell you that the autopilot occurs. Most people don't see that difference. And I think that's where we have an awful lot of difficulty and trouble today.
Yeah, I know. So that's okay. So is there anything, like when you talk to customers and AI is the hype word now, right? Machine learning is probably a bit less, but everyone says we need AI, we need to improve our business, we need to get the edge on the competitors by making this amazing machine learning algorithm. So what is it that people come to you and ask you for? Is it AI or machine learning or both?
It's all about marketing. AI is the current marketing term for the same stuff I've been doing for 15 years. Previous to that, from a marketing perspective, it was called machine learning. But you know how things are in marketing. Marketing people are fickle and they get bored with an idea very quickly. And as soon as everybody uses a term, every marketing person says we need something fresh, even though they don't need something fresh. They need good old-fashioned reason and thinking and logic. So currently AI is the go-to marketing term for essentially machine learning. What my customers come for and ask for are thankfully good old boring things like help us reduce fraud. I've just been working on 2 fairly large fraud detection projects I can't talk about them. I just realized yet. I will be able to name some of them later, but one in the public sector, one in the private sector. And in both cases, they just want to reduce fraud that is too expensive to catch, kind of obvious sometimes flying a little bit under the radar, not so obvious. And yes, we are going to use machine learning to build a better way of spotting it. But are they building AI? No, even though they think they are. Truly to be artificially intelligent in fraud detection, you would have to make autonomous decisions. In other words, automatic decisions by means of software. And subsequently, you would refine the decision making based on the results of those prior decisions. In other words, you have a loop in which actions of the model influence the model through the reaction and affect the way the model works tomorrow and the day after. In this particular domain, we do not want to do that because autonomous decision-making, automated decision-making, when it comes to things like fraud detection, using a probabilistic model, in other words, using a model which is always uncertain, thankfully is illegal in almost all of European Union. In fact, all of European Union nowadays, and in many other countries outside of European Union. GDPR has been one of the best developments in terms of what you can and cannot do using computers in the last few years. And I may be a bit contrarian for saying that because a lot of people complain about GDPR, but GDPR has established certain ground rules. One of those ground rules is that automatic decision-making about things that affect people's lives is something people have the right to refuse. And if you do make automatic decisions, they have to be explicable. So both of my clients don't. Both of my clients use machine learning to guide a human decision, but it's always the human who makes the decision. Essentially, is that AI? No, it's not, because the decision is not autonomous. But you could say that it was AI that sold me into those projects because originally that's what they heard and that's what they thought they wanted. And I think this story repeats itself a lot. I often hear people talk about AI, and very often they don't even need machine learning. Sometimes all they need is classical BI, business intelligence. Goodness gracious, so many projects can be solved by giving people a better aggregation, a better way of rolling up data, a better chart. Sometimes it's statistics they need. Just let's calculate a better average with a better measure of dispersion. So AI is great because it sells so many projects.
Yeah, that makes total sense. So how has it changed over the years? Because as we talked about before, right? I remember the data mining addins. That's really where I started. And knowing about AI, machine learning, I still haven't really, I dabbled a bit with R and Python, but I didn't do much. But how has things changed over the years?
Obviously, an awful lot. So first of all, those data mining add-ins, we still haven't got anything as good as them. They were amazing because to those who are viewing us, this is a little bit of Microsoft history, I suppose. Up to version of Excel 2013, and if you know what you're doing, even 2016, you could have installed those add-ins that provided rudimentary machine learning, or as it was called at that time, data mining algorithms to users of Excel, with the engine that processed your requests residing inside SQL Server analysis services. So that was, so to speak, the brain, and the UI was those add-ins to Excel. They were amazing because they simplified. Some people say oversimplified, but in this case, I think it was simplified just perfectly. What a typical user wanted to do with their data without having to learn about machine learning or data mining. And those canonical examples of what you want to do with your data, like highlight exceptions in this data set, show me what's wrong in my data, or if this is an important column, tell me what other columns seem to be related to it. Or if I have these transactions and people, tell me who is related to whom. Such very simple applications are still needed. Almost all of my customers start their journeys with AI, ML, data science through some form of show me the exceptions. I wish we had that functionality at that level of simplicity in other tools. And I realized that quite a bit has been done in Power BI, and I certainly like what has been done in Power BI. But, that's in Power BI. We need it brought to the level that everybody has access to it. And I'm missing that in Excel very much. Excel is the number one tool used by people who work with data worldwide. Number two tool is SQL, not necessarily SQL Server, but any SQL. Number three, number four, interchangeably are R and Python. Nowadays, Python leads because it is a general purpose language that people use for everything from scripting to machine learning, whilst R is specific to data science and machine learning. But Excel is still the number one tool people use. And I wish we had those data mining add-ins in a more modern version over there.
Yeah, I think our goal obviously is to make Power BI as available for everyone to play with. But yeah, definitely makes a lot of sense. So if you, let's say I'm a company today and I want to start doing AI, and you kind of already talked about it a little bit, but AI and machine learning, what tools are there and what products are there that you should think about?
There's too much. There are so many products that I can give you two answers. First of all, I can say that almost anything you will use today will work because all the tools that have survived that initial era, that explosive growth of ML tooling that are still in use, they are all highly capable. Having said that, the number one thing you have to decide is whether you want to dive into code first approach. In other words, you are at heart a software developer and you are prepared to learn Python, R, or C# or whatever programming language you wish to use, and use that as your gateway to machine learning and AI. Or approach number two, you are more of an information worker type of a guy or a girl. You want to work with information. You don't care about programming, but you still want to have the benefit of machine learning. And that second category is where, surprisingly, we still don't have enough tools. And most certainly, we don't have tools which were as easy to use as those fantastic data mining add-ins that we both cherish so much. And by the way, I still use them while I'm teaching. I have an old VM which I tend to turn on whilst explaining some aspects of ML because the visualizations that came with those tools are still some of the best on the market, like the decision tree visualizer in the add-ins is incredibly good. Anyway, to those who want to do the information worker approach first, where the tools are thinner and perhaps not as easily found and accessible, Microsoft's Azure machine learning is by far one of the best developed. And this is also one of the advantages that Azure has over the other clouds. My customers use Amazon Cloud and the Azure Cloud evenly, very often a little bit more of Amazon for compute, and very often a bit more of Azure for machine learning and this kind of stuff. And that's my customers. I'm not generalizing here about the world. And the reason is very simple. Azure Machine Learning comes with this fabulous designer tool, which uses a drag and drop approach that lets you quickly prototype and experiment with machine learning and AI without having to know too much about the code's SDK and the nitty-gritty of data types and all the stuff that software developers like. And that's absolutely the place where I would like people to start. To make things a little confusing, there are two variants of it. The really easy to use, free, nothing is required, Azure Machine Learning Classic, and the more capable, but you have to pay for it, and is slightly more convoluted at times, but more capable, Azure Machine Learning Designer, the new one. I use both, and I recommend that people look at both. And if anyone wants to study that, that's what I teach on my 5-day courses. This is the best way to get into machine learning. I'd say, even if you don't have a Microsoft background, I would be suggesting these tools because they are so easy to use. However, if you are a developer, or if you already know something about machine learning as a company and you want to build your capability in coding machine learning stuff, you will need to learn both Python and R. And the reason I hesitated for a moment is because I never know which way around to mention them. Because if it was up to me, I would say R and Python, because R is a programming language designed for this purpose. It's a language designed for statistics, for analytics, and for machine learning. But it is a purpose-designed language, which is not suitable for other applications and other purposes, and it can be quirky, to put it mildly. Python is a beautiful programming language designed for every possible use, and sure, it has, like R, some deficiencies. Both languages are not the fastest beasts on the planet, to put it mildly. Python happens to be a great doorway to a lot of libraries, SDKs, and frameworks for machine learning. Anybody who thinks that they can do everything in Python is right. Anybody who thinks they can do everything in R is right. But the best way to do it is to know both and to mix and match depending on the type of work you do. And that would be my recommendation to anybody, especially companies who already have some skills in that, is to invest both in R and Python. Do not choose just one of those two.
That makes sense. So maybe another question then too, because you were kind of already talking about it, but what type of users of machine learning and these features are there? Like you have a developer, you have a business user. That's it? Is it generally those two type of users? And how? Because I mean, I have a hard time imagining a business user going to Azure and spinning up some machine learning tool, and then what? How do you get to the data and all these things? So that's pretty complicated, I guess. Maybe you can talk a bit about that.
Absolutely. So first of all, let me get straight to the punchline that there is still this information worker type of a user for whom the likes of Power BI are very suitable. But before we get to that, what you said about Azure ML having to spin things up and to figure out how to get data and all of that, that applies to the new Azure machine learning, which is more difficult to use and more capable, but it does require you to basically to do a little bit more work. The older machine learning from Azure, which is still there and will be probably for a very long time to come because there are a lot of users of it, is the Azure Machine Learning Classic. That one, you don't need to spin anything up. You don't even need an Azure account. You literally provision a Azure Machine Learning Workspace free account and off you go. So if you just want to get started, if you want to do some experimenting, learning, and so on, there is nothing to spin up or worry about. And it's incredibly easy to get data into it and all of that. And that's why I'm such a fan of it, because for as long as it's there, it's one of the lowest barriers of entry to GUI first, graphical user interface first, as opposed to code first approach into machine learning. And I think people who use one very quickly realize that they need a little bit more power. They've done their prototyping. That's where the new Azure machine learning, the one that you need to spin things up, and its designer come into its play. Now that I've done my prototyping in the cheap, quick, and easy one, I have a reason to invest my time into the other tool. With Python and R, the same. You can write Python and R on your laptop or on a server. SQL Server happens to have fantastic SQL Server machine learning services built into it, which give you by far the fastest way to score or predict on production loads. Not a particularly complex server setup will give me production predictions on a nanosecond per row scale. Getting 20 nanoseconds per row is I wouldn't say child's play, but it's very easy. It's an incredibly fast machine. And that's another place where perhaps the more advanced user may want to go. And that lets you use Python and R. You can also use Python and R with Azure Machine Learning, both the old, in a slightly clunky way, and the new. This is where the new one really shines because it's been redesigned from grounds up to be very friendly to Python and R approach. Python probably a little bit more than R, but R is also quite capable there. However, those are the dedicated users. Those are the users who have a mission. They probably have a boss in the company who has already justified the need for a project that is machine learning in nature. The information worker is still underserved. So We're talking here about, for example, without naming any names, one of my clients happens to be the head of a fairly big investment fund in the States. And he wants to look at a data set and just quickly find out what's wrong about it, what's questionable. Show me the rows which don't fit the rest. When I showed him the data mining add-ins, he literally fell off his stool. And that was only a few years ago. So those tools were already quite old. We need more tools for that type of a user without making them learn about machine learning. Power BI does a lot in this space, but I think Power BI needs to go a little bit further. The best place in Power BI today to use machine learning requires a little bit of knowledge, and this is that fabulous connection between Power Query and ability to consume models that somebody built for you in Azure ML. So you can have your expert build your Azure ML models, and they are very easy to consume using Power BI, using the Power Query component of it. Power BI also comes with a few tools that give you intelligence, and those tools go quite far, but I really want someone to copy those data mining add-ins into Power BI almost verbatim. And one aspect where Power BI does it is one aspect where I'm not sure whether I love it or not. Power BI introduced in 2019, I think that was previewed in 2019, the ability to use automatic machine learning, AutoML. I'm never quite sure whether I love or hate AutoML. I'm certainly more accepting of it nowadays because for an information worker, it's a useful tool. But it's also a tool that can quickly get you to the point of building something you don't understand, but you think you understand, and to reach wrong conclusions based on a tool which is almost a little bit too powerful. AutoML is a tool based on Azure behind the scenes, Azure ML behind the scenes, which basically tries every algorithm it has access to on all of your data, and it performs a pretty impressive amount of automatic data preparation for you. But all of this is based on let's try everything and see what works and what doesn't approach, rather than a more guided, thoughtful approach.
Yeah, whatever sticks.
So if you are lucky, then it works. And if you're not lucky, you get something that you excitedly go to show to your boss, and you realize that the boss then says, I don't think so. And you can very quickly curtail your enthusiasm that way.
One of the questions that I wanted to ask about the AI, machine learning, and all of these things is, so there's so much information. There's so much things that I can do. Where do I go to learn?
Oh, thank you very much for asking that question. So, funnily enough, you would be delighted if anybody who really wants to learn studied it with me. I've trained over 900 data scientists just in the last very few years on it, and many more if I were to count the previous versions of these courses. If you really want to get started, Azure ML is a great place, and my course goes into everything you need to know right from the very fundamentals. I actually have a slide on that, if you don't mind me sharing, Kasper. If it's my course, then this is what you learn. And if not, this is what you need to learn somewhere else. You need to start with the fundamentals. You need to understand, above all, how does it work, what it can and cannot do. Then you need to set yourself up. You need to know a little bit about the software, for example, how to put all the bits and bobs of Azure ML in place. Then you need to learn about data. Data for machine learning is prepared in a very unique way, which has nothing to do with how you structure data for relational databases or business intelligence, nothing to do with data warehousing and so on. And that unique format is fundamental to understanding also what you can and cannot deliver from your models. Then you need to learn how to build models. There is a well-known pattern how this is done that we repeat over and over, and you need to understand everything about it. Once you know how to build a model, you need to figure out how to connect it to your business. In other words, how to translate your boss's question of, oh, I want to improve my sales predictions into what am I actually going to model? What are the inputs? What are the outputs? The process of data science is a fundamental tool for that. You need to know about algorithms. This is the most exciting part and the easiest one to learn. There's way too many articles out there and videos which explain nitty-gritty of clustering, regressions, anomaly detection, decision trees, and neural networks. Whilst this is important, this is only one component of learning ML. The most important thing you need to learn is how to validate models, because it is child's play to build a model which doesn't work. Anybody can use automated tools, including AutoML, to build models which will not work once deployed into production, even though they seem to work very well in your lab. The problem is that most people learn about some aspects of model validation and not the important ones. One of my biggest concerns in the last few years is that the quality of people leaving universities, schools, and colleges in terms of machine learning is so over-focused on model accuracy that they almost don't know anything about model reliability. People nowadays are very good at over-tuning models' perfection to the point that they only work on artificial data that was used for training purposes in the lab. And once they deploy them, they start breaking down. This is known as a highly accurate but an unreliable model. And if you are new to it and watching this podcast and you are wondering why, study this a little bit more. It's all about bias and variance if you want to learn it from a technical perspective, or simply accuracy and reliability. And finally, you need to learn about deploying those models. And there are many ways how to do it. And I, of course, cover that also on my courses. But even if you don't study that with me, if you want to learn out there, there's plenty. Techflix.com, Microsoft's own Channel 9. I'm not going to even mention the likes of YouTube. There are a good few MOOC courses from EDX, Coursera. There's plenty of places. Probably start with a tutorial of some sort. But above all, make up your mind whether you want to start code first, and you're going to do it first by learning Python and R, or whether you are interested in learning machine learning first, and then decide on the languages, in which case Azure ML is really a great place to start, especially the classic version. No cost, no barriers, and you'll be going in about 15 minutes as soon as you press the buttons.
All right, thanks, Rafal. That makes a lot of sense. So maybe now let's go back to Power BI and AI and machine learning. So in the Power BI team, we've been talking a lot about citizen data scientists. That's really the audience that we want to grab. And I think similar to the business person wanting to do AI that we were talking about before. How big is this market, you think? And how important is this actually? Because we have so much amazing calculations and algorithms and all these things available, but it's so hard to get your hands on it. And also to make it understandable, right?
Yeah. This market is as big as the market for Excel. And I remember talking to some of your colleagues in charge of the Power BI team over many, many years. And that vision of having 500 million people using Power BI as they use Excel, that is the market. It's definitely enormous. The question is whether there is a simple enough canonical example of the type of advanced analytics that machine learning supports that we should be enabling in these tools as a matter of priority. And is Power BI doing that or not? And I think the answer to the first one is yes, we know that. This is where the data mining add-ins have done so well in the past until they got abandoned for various reasons of software incompatibility, the team being disbanded at Microsoft, and the whole drive away from server-centric architectures towards distributed architectures. But I think Power BI is doing the right things. As long as we have the capacity to do the simplest things, like highlighting exceptions in an easy way, I think that would work. The problem is that Power BI has never really been designed as a replacement for Excel, but as something else. What I need is a row-by-row view of data showing me pretty much Excel spreadsheet and highlighting the exceptions. If you think about Power BI, it is everything but that.
Exactly.
Power
We don't
BI
want to be
is all
that
about
either.
aggregation. I'm sorry?
And we don't want to be that either. Exactly.
And that's the point. Power BI is going in the direction of clever aggregations, beautiful visualizations and plots, and doing BI, doing what we had to use cubes for in the past. And now we can do it in Power BI. So that's why the most canonical, the most basic example of citizen data science that I see is still not implemented in the tools of our choice. And
so what do you like about
Microsoft,
So
go ahead.
what do you like about some of the new things that have been added? Like when you go in and like say, like, okay, explain to me why this line is going down, or why this chart is going down, or explain what the relationships using the decision trees and things like this. So it is more or less like ingrained into the visualizations than, as you said up front. So that's really and probably is based on the reasoning you said, right? Because Power BI does aggregation. So it makes sense if you can look at the data and then put AI and machine learning on top of that.
Yeah, all of that is very good. And I'm delighted that that functionality has found its way into Power BI. But those are not the easiest, lowest hanging fruit. If you ask me for the easiest, lowest hanging fruit, then just copy the data mining add-ins for Excel. Except, as we just discussed, almost none of that fits into the Power BI way of doing things because Power BI is designed for a different purpose. So what we really need is to go back to Excel. The Excel team needs to reconsider adding those things back. But I haven't seen the Excel team developing Excel in any significant way for a number of years. It's a fairly static product right now. So I don't know what the chances are that this will happen or not. But where Power BI uses machine learning right now at the citizen data scientist level, I think it does well. What I would like Power BI to do is to incorporate a little bit more of rudimentary statistics that we need to make easier for people. So nothing to do with machine learning, but actually going back to the basics of it all, being able to compare two data sets using a visualization that shows a correlation plot would be a nice low-hanging fruit. In fact, doing box plots in Power BI. I've been doing box plots and correlation plots in Power BI for a long time by using R. And people who study my more advanced course, that second course, which focuses on R and SQL, we actually use Power BI for a part of it. And Power BI houses R visualizations for us, which we use to deliver the things that built-in Power BI visualizations don't do, which statisticians like very much, like, for example, box plots or correlation plots. But there's an awful lot of very rudimentary statistics that I think we should challenge the Power BI team with making easier for people. For example, there was an era which has pretty much passed when we were building dashboards everywhere. I'm sure you remember it because we were both very excited about various dashboarding tools the last 10, 15 years. And one of the things that dashboards were very good at was displaying key performance indicators, KPIs. For example, the average sales now compared to average sales last month. And that's still done, and that's still very easy to do using the likes of Power BI, especially the reports, which you can do using the Power BI service on the web. Where I think we are missing something is educating the user that actually they shouldn't be comparing 2-point averages against each other. Comparing average this month against the average last month, when they look like that, that looks good. That average is higher, that average is lower, therefore we are moving in the right or wrong direction, depending which way around you look at it. Very often, what is really happening is that we are not comparing a point with a point, but we should be comparing a range with a range. Very often, business decisions are made on tiny differences between averages, which any statistician would not dream of comparing. A statistician will say, don't look at a point, look at a point and its range or dispersion or standard deviation or interquartile range, or there's many ways in which we can describe that range. But as soon as you display a point with its range and a point with its range, you will very often see that what looked like a higher average actually happens to be two overlapping ranges. And therefore, we can no longer say that things have improved or disimproved because there's a difference. There's actually no statistically meaningful difference. This is something we can very easily visualize using all sorts of cute plots and things. I wish Power BI was making that a little bit more obvious to the users. And maybe that's where that citizen data scientist could grow, by using tools which guide them a little bit more in how you should be thinking about data. We do that in Power BI using R, but it would be nice to have that as a more native functionality.
Yeah, that makes sense. So maybe another question, because I know that's there too. Like you can also connect your data, and when you import data, to models that you've already created in machine learning, right? So you could actually go ahead and, like I said, maybe in my organization, we've built the experts in my organization who know everything about machine learning. They've created some models that are very particular to my organization, but they can now give it to every person who's running Power BI, who's importing data, who wants to know more about customers or products or whatever it is. How do you see that? And do you actually see it happening? Do you see people making machine learning algorithms and then giving it to the business users or information workers?
Yes, I see that a lot. That is, in fact, how almost all my customers implement the actions of their models. The models, say, perform a prediction of maybe some fraud scoring, or predicting which products will break down, or which customers need to be contacted first, or what promotions to give to whom. The issue is that it is very easy to build those in Azure ML, and it is very easy to consume them in Power BI. But Power BI is not designed for a row-by-row display of information. What most of my customers do is output this into an Excel or a CSV, because that's how they carry data. However, those customers who are then looking for an aggregation of it, or they want to take a slice of it, in other words, they want to not see the underlying rows, but some further processing of it, whereas the prediction is a column that, for example, drives a slicer, they use Power BI exactly for that. So Power BI, as long as we use it for what it was designed for, is very easy to integrate with machine learning. And yes, we do that, and my customers do that all the time. I guess what I'm trying to say is that an even bigger use case for machine learning is when Excel happens to be the output, because all people really want very often is just a bunch of rows with filtering, with sorting, all the things that, for better or worse, Excel has been doing extremely well for a long time. So yeah, there is place for both, and I would always be the first one to say that I believe it's Microsoft's mistake not to have developed Power BI and Excel together for longer. But I completely understand why, for organizational, structural reasons, separating the Power BI team was the very best thing to do, because it allowed us to have this great product that would have never happened had it been continued under Excel. But that's organizational structure of Microsoft aside. What the user really
I'm not sure it's organizational structure, but actually we talked about this in the last episode with the Mir Nets too. Like There are two different beasts, so it is a different. I don't think we would have won, and as you said, like we wouldn't have had Power BI if we would have gone down that route. So,
I'm 100% sure that you are right, that had Excel team retained its control over Power BI would be forgotten by now. Yeah. Which is a criticism against the Excel team. And the Excel team needs to get their act out if they want to grow this product into the remainder of the 21st century. But I think there's also they don't need to.
Well, I mean, they don't need to, but it's also not that easy to actually ship features in Excel, like because you have the potential of breaking a billion users. So how many there are? I don't know how many, but all right. So maybe and because we're obviously talking a lot about Power BI, what are some tips and tricks that most people don't know that they can do with Power BI in combination with AI machine learning that you would think they should know?
Probably the number one tip and trick is not even with machine learning, but with data science. For me, by far the best and not very highly explored region is the intersection between Power BI and the R and Python languages, but in particular R. R comes with a fantastic library for visualizations called ggplot2, which is part of an ecosystem known as Tidyverse. Many organizations around the world have standardized all of their visualizations on ggplot2. BBC, the New York Times, many parts of the United Nations. In fact, BBC even publishes a package that lets you get your plots look like all of the BBC plots, and so does the New York Times. And the quality of those visualizations is astounding. You can have all of that in Power BI. Now, Power BI has a lot of visualizations, of course, and they work very well. But very often, you want something that Power BI doesn't quite have. And you go to the gallery and you search for it. But, funnily enough, a good few are developed using R over there, and people just republish them as such. But that's such an easy thing to do. It requires almost no knowledge of R. You can learn it in a day, and then another day of playing with ggplot2. That would be definitely one of my first tips for visualizations. You can also use this intersection to generate data that you then display using normal visualizations in Power BI. This is a very common use for me and my customers, where we do forecasting using, for example, R and the forecast package in R. And we do all sorts of complex and fabulous ways of decomposing the data and making sure these forecasts are accurate. But we still want to visualize them using a line chart, or one of the very simple things that Power BI has, because it then connects nicely to slicers and whatnot you have. Nothing to do with machine learning, but everything to do with data science. You see, data science uses machine learning too, but it starts really with statistics. And it is that area that I think is a gaping hole, an obvious gaping hole, where Power BI can be of great use, and vice versa to people who already use Power BI. That's where they can get extra chops using well-known statistical techniques. When it comes to the intersection with machine learning, on the other hand, the primary use case is the one you've already outlined. So build a model in Azure ML, publish it, and it's dreadfully easy to consume in Power BI. So you can perform scoring by calling your service in Power BI. The difficulty is that that's not the most typical use of machine learning. This is really of use if you are going to use ML to create some intermediate data that you will then aggregate in Power BI. And if that's your need, which may be absolutely the purpose you are looking for, that's definitely something I would be looking at. It is a bit buried. It is somewhere in Power Query, which then means that if you want to put it on the server, it becomes a question of a data flow. And if it is a data flow, then it is a little bit more convoluted how you automate it. So maybe not for the faint-hearted, but definitely this is a good place. So sorry, Kasper, if my tip is really not about ML, but by far, just combining R and Python visualizations with Power BI, a no-brainer for me. That's what I do all the time.
Makes total sense. So maybe one last question, or almost last question. So we talked about machine learning and AI. Another term that's getting used a lot is predictive analytics. So how is that comparatively, and how can we use it even in Power BI today or in any other tool?
Oh, absolutely. In fact, we've been talking about it. Predictive analytics, for better or worse, is the name that replaced data mining and that preceded what people now call machine learning from an information worker's perspective. Of course, not all analytics is predictive in nature. Very often, you just want to see what's in the data without predicting anything. So predictive analytics as a term is a little bit specialized. But for example, forecasting is an example of predictive analytics. So when I was talking about building a forecasting model using forecast package in R and displaying its results using Power BI, that's a good example of combining the best of both worlds. This is machine learning, this is predictive analytics, and this is Power BI. From Power BI's perspective, because it's so good at aggregations, because it's so good at slicing, because it's so good at giving you a dynamic way of visualizing information and playing around with it, this is a nice place to think about predictive analytics, because you can use predictive analytics to predict things which you then test and validate by aggregating them. So, for example, you could build a model that predicts what your sales would be based on some parameters of products. And now you could modify the parameters of those products and see how the curve of your sales changes. Power BI is an ideal tool for visualizing that, because I don't need to see the row by row data. All I want to see is the curve, the aggregation. So my model, which is predictive in nature, machine learning model, which is predictive in nature, could be running locally on this machine in R or Python if it's small enough. And a lot of forecasting models require almost no computing power, so they can be run locally. So you could do it even in Power BI desktop very easily. Or if it's something a little bit bigger or beefier, maybe it's running in Azure ML, and we are consuming it from Power BI. So the predictive model, wherever it is providing an additional data point, a column, which we never want to display on its own. We merely aggregate it, for example, over time, and we have some line chart, or we aggregate it and break it down by some categories, and we have slicers or whatever other visualizations we want to do. I don't know if you remember in the olden days, well, many of my customers, they still use it. We had this technology in OLAP cubes, write-backs that were used for predicting. Remember? That was a big feature, where you could see how your aggregates would have looked like if you had slightly different data. Well, this is, in a way, a variation on that theme, except we are not writing that data back. We are actually predicting that data and then re-aggregating it. So whenever you think of aggregations and data that could be predicted, that's a match made in heaven. Power BI and either Azure ML or Power BI and some R or Python code running locally, that works very nicely. And I've done that many times.
Yeah, that makes total sense. So maybe the last question. We're kind of running out of time too. What are you most excited about in the future regarding machine learning AI? I mean, I think it's moving pretty fast. And I'm not the one who's keeping up with everything that's going on there, but I hear it all the time. Satya talks about it on stage all the time. There's lots of interesting things happening everywhere. What are you excited about?
What I'm really most excited about is a solution to the biggest problem of machine learning that we have today, and in fact, of AI that we have today. So earlier in our talk, we talked a little bit about black box and the problem of algorithms which are inexplicable, problem that leads to death, self-driving cars which are, suddenly swerving left for no apparent reason and crashing into a parked fire truck. I could quote many examples of
Yeah, the
of
ghost brakes at
situations
Tesla,
where, yeah,
phantom brakes.
yeah, it's a car I drive, the best car I've ever had. But as an expert in the area, I am greatly reserved about the capability of what they call automatic. What do they call it now? Fully self-driving capacity.
Yeah.
Probably the biggest lie in marketing that has ever been invented. There's nothing full self-driving about it, and that's another. If I want to really complain about something, get me on that, because I will talk later a lot about how it's not appropriate to suddenly stop acting autonomously and require a human intervention within 10 milliseconds to prevent a crash from occurring, at which point, of course, nobody has a chance of recovering that. And anyway, this is another subject for another chat. The point is that these black box algorithms and those models don't work for edge cases. They don't work for those rare situations. And they have no chance ever of working if they are built in a probabilistic way. But there is a solution. And the solution is to go back to actually our artificial intelligence roots. When I studied AI, I studied in the 90s. I studied before machine learning was used to do AI. I am very lucky to have studied under some tremendous people. I've studied under Kowalski and Frank McCabe, who invented programming in logic, Prolog, microprolog languages. These guys have created the original environment based on logic and reason for making autonomous decisions. And the reason I'm stressing the word logic and reason is because when you use logic and reason, you generally don't make mistakes. You do not have fuzzy machine learning or maybe not. You have yes or a no. But it's not powerful enough. So what am I excited about? Combining them together. For the last 6 years or so, I've been banging at every conference on about how we could combine the best of machine learning and probabilistic decision making with the best of that older era of AI created in those days in Prolog or Lisp, or maybe Haskell and Clojure and F# and some of the more modern languages quite suited for this purpose. But really, it's not about languages. It's about using logic. It's about formalism. It's about ontology. It's about a more structured way of thinking where you could code for those extreme situations, making sure that the car never does anything stupid. Or if it's going to be doing something stupid, it disengages way ahead and not in the last 10 milliseconds when you know that the person is going to die. That excites me because that would enable us to combine the best of probabilistic systems, which are pretty good at distinguishing cows from dogs, but not always one human being from another, with the best of logical systems. And I think this will happen. We probably need another 10 years. If we are lucky, maybe 5 years, but somewhere about, I'd say 2030, 2035. I hope to see real artificial intelligence, not just this, Mickey Mouse thing that we today are so enamored with, and we think it's amazing, but in fact, it's not. In fact, it's a lot of fun. But fun shouldn't be always applied to life-death situations, as examples show. So, in a way, I'm just excited about the fact that we'll fix some of the problems that are currently plaguing our field so much.
Of course, makes total sense. All right, and I think with that, we're at time. I really want to thank you. I think it was very interesting. I learned a lot of things about AI, machine learning, and using it inside of Power BI. And because the only thing I really know is DAX modeling, and Power BI alone is so much to keep up with. So this extra space, and this is why we're doing these episodes, to really learn about these things. I really want to thank you, and until next time.
Thank you very much, Kasper. I look forward to chatting again, and I very much appreciate that. And I'm sorry if some of my comments came across as a little bit too direct, but I've been in business for long enough. So I come with a warning. Please make sure to validate everything I said in case you don't agree with it. And thank you for the opportunity.
Of course, and I've known you for many years, so that's why I have you. All right.
Thanks. I
Thanks a
appreciate
lot.
that. That was wonderful. Thanks.
And that concludes another episode of Kasper On BI. I hope you've enjoyed it. I've learned a lot. AI, machine learning, what you can do in Power BI with it, which tools you can use, where to learn. So with that, if you've liked it, hit the like button. Subscribe if you want to hear more. There's many more things coming down the road. And with that, I wish you a good day.